Welcome to the PH 4410 review on the minimal spanning tree. In previous video reviews, we have gone through spectral filtering of the cross-correlation matrix as well as threshold filtering of cross-correlations. Now we come to a very popular method of actually picking out the most important cross-correlations in a dense cross-correlation matrix, and that is the minimal spanning tree, also called the MST. Now we start from two time series xi and xj. Okay, now suppose their cross correlation is Cij, and we know that this ranges from -1, which is anti-correlated, to 0, which is not correlated, to +1, which is correlated. Okay, and we want to define some kind of distance measure based on the cross-correlation matrix. Now there is a mathematically rigorous definition of distance in terms of the cross-correlation, and that is the ultrametric distance. Okay, Dij equals to square root of 2, 1 minus Cij. And you can see that Dij goes from 0 to 2. So 0 when the two time series are perfectly correlated. So this is when Cij is +1. And then 2 when the two time series are perfectly anti-correlated. Now, so if we graph this distance as a function of Cij, okay, the plot Dij in terms of Cij, we will find that it looks like this. Okay, this is +1, this is -1, and this is 2, and this is 0, and so 0 correlation is somewhere around here. So it is a square root function vanishing at +1, but otherwise it is monotonically decreasing. Okay. Now, in the computer science literature, you can also find a different definition of distance, starting from the cross correlation, and that is some kind of a linear distance, Dij equals to 1 minus Cij. So again, Dij goes from 0 to 2. It is 0 when the cross correlation is +1, and 2 when the cross correlation is -1. Same range, but this is such that Dij is equals to 1 when Cij is equals to 0. So the zero correlation partitions the distance into two equal halves, and we can see from the graph that how this is the case. So this is Cij. We go from +1, or we go from -1 through 0 to +1, and it comes down as a straight line like this. Okay, so this is when this is for Dij equals to 1, and this is Dij equals to 2. Okay, now what we should notice, of course, that these two functions are of course not the same, and in fact the linear distance does not satisfy the triangle inequality, which is required of all distance measures. But for the purpose of constructing the MST, actually we do not need a distance measure that satisfies the triangle inequality. More importantly, the ultrametric distance is a monotonically decreasing function of Cij, and so is the linear distance. So monotonic, which means that actually the two MSTs that are constructed this way would be the same. But what is the algorithm that we would use to construct the MST? So let me give it here. The algorithm that we would use to construct the MST would be such. First, we start from the smallest distance. dij, and we draw a link between I and j. Okay, then we go to the next smallest dij, and if drawing a link between I and j gives no cycles, we accept the link, else reject the link. Okay, and then 3, we if we all nodes are incorporated into a single graph, stop. Okay, else go back to step number 2 to continue adding links. So this is the MST algorithm, very easy to do. Of course, this is agglomerative. It is also possible to get the MST through a dissociative algorithm, but it is much easier to understand it from the agglomerative point of view. And let's do a simple example. So let me clear the thing and just create a random matrix. So let's create a random correlation matrix. So let's say it is just 8 of them. Okay, so in this way the matrix is actually not symmetric, so we symmetrize it. Okay, this symmetrizes the matrix, but the diagonals are not 1. Although it is not particularly important, let's just make it look really like a correlation matrix by making the diagonals 1. So now the diagonals are 1. Let us now copy. Let me bring it to one corner so that we have space. Okay, and I'm done. And what we now need to do is to go through these cross correlations. And I forgot to mention that if going from the smallest distance to the largest distance produces the same MST as going from the largest correlation to the smallest correlation. So we will proceed by going through the correlations. So let's see. Look only at the upper triangle. So let me mark out the upper triangle. The upper triangle would be from. So I'm cancelling the diagonal. So anything above will be the upper triangle, and we can see here that there is a large there's a large correlation value, 0.86. Anything larger than 0.86, there's a 0.859. So there's a 0.88. So this is the largest. This is the largest correlation, and it is between number 8. So this is number 8. This is number 6. So this is between 6 and 8. So let us draw 6 and 8 first. 6 linked to 8, and put the number 1 here. So this is the first one that we have accepted. Now let's proceed to find the second largest. So earlier on we've said that 0.865 is the second largest. So let's highlight that. Okay, and this is between number 2 and number 3. So this is between number 2 and number 3. So let's draw that. So it's between number 2 and number 3. So this is the second link to be added. And the next largest correlation is here. Okay, and it is between number 7 and number 4. Okay, so between number 7 and number 4, let's draw that as well. So between number 4 and number 7, and this is the third link to be added. So next we continue our search for large correlations, and there isn't any other correlations that are above 0.8, but there is one that is 0.758, and well, nothing larger than that. So this is the next largest. It is between 4 and 8. So it's between 4 and 8. If we link 4 and 8, will we produce a cycle? The answer is no, so therefore it is accepted. This is the fourth link to be added. So now we continue to look for the next largest. So no more 0.7, how about 0.6? So there is a 0.64, 0.669, 0.60, 0.61, 0.69, 0.60, 0.62. So this is the next largest. It is between 1 and 7. Now 1 has not been added yet, so it is easy to just draw a 1 here, connect it. This is the fifth link to be added. So there are only altogether 8 nodes. 1, 2, 3, 4, 6, 7, 8. So only number 5 is missing. So let's continue to go through the correlations. So this is 0.69. The next largest one would be 0.66, because there's no 0.68. So this is the next largest, 0.66922. And this is between number 4 and number 2. Number 4 and number 2. Can we join it up? Will we get a cycle if we join it up? The answer is no, so we join it up. So this is the sixth link to be connected. So we are almost there, just missing node number 5. So after 669, who should we use? What correlation should we pick up? So there is 64, and there is 6462. So 64 is the next largest. Where is it? Here. Okay, it is between 1 and 4. It is between 1 and 4. But if we join 1 and 4, so if we join 1 and 4, it will form a loop. So this is not acceptable. So we have to ignore this particular link. So I'm erasing it again, getting rid of it. Okay, and so this is not acceptable. So not acceptable. And then the next one will be 0.62. See it, 62 here. Okay, 62491. It is between number 3 and number 8. Okay, number 3 and number 8. But if I connect these two, then I will form a loop. So this one is again not allowed, not accepted. Then 61. 61 is between number 5 and number 2. So number 5 and number 2. This is okay because 5 is the last node to be added, and it's never been previously added. So we now finally added 5, and this is number 7. And with this, we will have obtained the final MST.